Hello friends, today I will discuss the numerical problems on superposition theorem with the DC circuits. So before I discuss this, let me consider the necessity of this theorem, then limitation of the theorem, then we go to the problem. The necessity of the superposition theorem is whenever we find a complex circuit consisting of several sources, and when you want to know the current flowing in any branch, it takes a lot of time when we apply the KVL method, that is loop method. Whereas if we apply the superposition theorem, we can calculate the current flowing in the branch that is under consideration without much difficulty. The limitations for this superposition theorem is to apply this, at least there must be minimum two sources in the circuit. And the another limitation is this theorem cannot be used for calculating the power in any branch or in any element. Now let us take a problem like this. Find the current flowing through AB branch in the following circuit using superposition theorem. So here we have the V1 40 volts and V2 is 5.33 volts, and this is 4 ohms connected in series with this, and this 4 ohms is connected between the terminals A and B, whereas the 2 ohms is connected in series with the 40 volts. So to get the current flowing through AB branch, so as per the superposition theorem, first we consider one source at a time and then find out what is the current flowing in this branch AB. And then we make it ineffective, means zero. Then we take this working, then we find out what is the current flowing in this. Then as a third step, we find out what is the resultant current in this due to the two sources. So let us see first. The step one is, in the first step we take the case 1, that is when V1 is present while the V2 is absent. So V2 is absent means voltage source must be short circuited like this. Then this is the resultant circuit. So for this circuit, find out what is the I1 dash. To get this I1 dash, we use the normal series parallel operations. So when you look at this 4 ohms and this 4 ohms are in parallel with each other, and that combination is in series with the 2 ohms. Then once we know the total resistance, so divide this 40 volts with the total resistance so that we get the I1. And once we get the I1, we apply the current divider rule to get the current flowing through this 4 ohms. So which we can see here, this 4 ohms and 4 ohms are in parallel, and that combination is in series with the 2, so we add that 2, and the resultant of 4 in parallel with 4 will become 2 ohms, so 2 plus 2 is 4 ohms. And now having known the resultant resistance of this circuit, now we can find out the what is the current supplied by this 40 volts. So this I1 is nothing but this voltage, that is 40 volts, divided by the net resistance with respect to this voltage source, which is already calculated as 4 ohms. So now we calculate I1 is equal to 40 divided by 4, so we get 10 amperes. But we need the current flowing in the AB branch, and let us say the current flowing in this is I1 dash. So we apply the current divider rule for this. So that is I1, total current is I1 into opposite arm. For this 4 ohms, opposite arm is this, that is 4 ohms. So that resistance in the numerator, then Sum the both parallel resistors. This 4 ohms and this 4 ohms are in parallel, so add those two. Then we get 4 plus 4. And I1 is already calculated as 10 amperes, so 10 into 4 divided by 4 plus 4, then we get 5 amperes flowing in the AB branch with V1 acting alone. Next, case 2 is when V2 is acting and V1 is ineffective. In that case, the circuit becomes like this. Now let us say the current flowing in the AB branch is I1 double dash. So to get this, first of all, calculate what is the total resistance offered by this circuit to the voltage source. So when we look at this 2 ohms and this 4 ohms are in parallel like this, and that combination is in series with 4 ohms. So we write like this 4 plus 2 in parallel with 4. So then once we simplify it, we get 5.33 ohms. So this is the total resistance offered by this circuit with respect to the V2. So once we know the total resistance and the applied voltage, I2 can be calculated like this. That is, I2 is nothing but voltage divided by the net resistance, that is 5.33. 5.33 divided by 5.33. So we get 1 ampere is the total current supplied by this source V2. Now, to get the current flowing through this AB branch, apply the current divider rule, that is I2 into opposite arm to the AB branch is this, that is 2 ohms, divided by, add these two resistors 4 plus 2. Then we get I2 is already calculated as 1 ampere. So 1 into 2 divided by 2 plus 4. Then we get 0.33 amperes. This is the current supplied by the V2 source in the branch AB. That too from top to bottom. Now, the total current supplied by the two sources as per the superposition theorem is nothing but IAB is equal to I1 dash plus I2 I1 double dash. I1 is due to the V1, I1 double dash is due to the V2. So when we add those two, then we get 5 plus 0.33 amperes. So that is 5.33 amperes is the total current supplied by the two sources put together to the AB branch. So let me consider another problem on superposition theorem. Find the current in the branch AB using the superposition theorem for the following circuit. This V1 is 12 volts connected across 5 amperes current source like this. Then 3 ohms and 2 ohms are connected in series, but the AB terminals are between 2 ohms. So to get this current flowing in the AB branch, so consider each source at once, making other source 0. So case 1 is when V1 is active and current source is 0. That is the first case. So because it is the other source is current source, it must be open circuited. So with open circuiting this current source, the circuit will become like this. Then find out what is the current flowing in the AB terminals. So this is series circuit. So whatever current supplied by this 12 volt source, same will flow through this AB branch. So that is 12 divided by total resistance 5 plus 3 plus 2. So that will become 10. So 12 by 10 means 1.2 amperes is the total current supplied by the V1 source. Next, when current source is present but V1 is absent or V1 is 0. In that case, the circuit becomes like this. So we short circuit the voltage source like this because making that to 0 and current source is active like this. Now to find out what is the current flowing through this, again apply the current divider rule, that is this total current into opposite to this arm is this one. So current source value is 5 amperes into opposite arm for this AB branch is 5 ohms. So 5 into, so this resistance, that is 3 plus 2, that is 5 divided by 5 plus 3 plus 2. So the current drawn by AB terminal or AB branch is 2.5 amperes. So I1 dash is the current supplied by the current source in the AB branch, whereas I1 is the current supplied by the voltage source. So to get the current flowing through AB branch, add I1 and I1 dash, that is 1.2 plus 2.5. Then the total current will be 3.7 amperes. So let me summarize once. So we have seen the necessity of the superposition theorem, and also we have seen the definition of the superposition theorem, and also we have seen the limitations of the superposition theorem. And then we have seen a problem in two problems with DC circuits. In one case it is only voltage sources present, whereas in the other case voltage source is present and also current source is also present, and we found out the current flowing in the desired branch using the superposition theorem.